I'm very pleased to introduce Axel Kern from LAWO, and he'll be taking us through his viewpoint on exactly what we should be looking for in this new interconnected world. So take it away, Axel.
Thank you very much, Wes. So it's good to be back. It's very, very good. And I'll be back with a very provocating title, The Good, the Bad, and the Ugly. And that's actually quite an offending title, I would say, on a industry event which we are all attending for a reason, which is we look for progress and innovation. Don't worry, it is not meant provocative. It is a title which catches your attention. That is meant for that. So it's an attention which I need for a topic of which I believe could use some real insight, some real life insights for a better understanding. So you may have wondered why the industry is making good progress with some specifications and standards, while other standards don't seem to get forward. And it takes a lot of time until they get really adopted. In the next minutes, I would like to try and shed some light into why some good ideas are somewhat hit by the ugly reality. So when a technological evolution transforms an entire industry like it currently does with ours, nothing remains as it is. We are moving our entire broadcast infrastructures to IP. We encode media signals into packages, stream them from A to Z. We use them over local and wide area networks. And we increasingly benefit also from our new infrastructures. We begin to rethink our workflows. We consequently break boundaries out of local installs and embrace advanced possibilities in larger global networks. And even our tools evolve, our workflows do as well. So these transitions trigger naturally the engineering departments at a manufacturer site in many, many ways. Engineers want to make things possible. They want to adapt to new technologies, they want to enhance existing product, they want to develop something new from scratch ideally, and this is what keeps us as engineers busy, curious and excited. The technological evolution of our industry actually, oh wait a sec, here we go. The technological evolution of industry deals with this huge transition, and it's a very fundamental one, by the way, even more fundamental than the transition from analog to digital. It is complex in nature and radically fast. Our industry is able to team up, which we did, and we pursued the higher goal of mitigation of rising incompatibilities by developing standards and open specifications to achieve a good level of unification across the industry, across technologies. The specifications for industry-wide technical unification have been perfectly summarized by the technical pyramid of the EBU, which is this one. And this pyramid perfectly visualizes various information. The first is, it shows the fields of application where change is applicable. So, for example, media transport, time and sync, operation control, configuration monitoring, and security. The second information it explains is the open standards and specifications which are recommended to be used in order to get along in those areas with your new products. So for example, in media transport, it's recommended to use ST211020 for single link video. It is PTPv2, which is recommended as synchronization for SMPTE and AES profiles. And the recommendation globally, industry-wide, for discovery and registration mechanisms is NMOS ISO4. That's all written in here. The third information the pyramid shows is that the current state of adoption has reached a certain level of progress. So there's color codes you see. It's green for complete or widespread adoption. It is yellow for an ongoing but partial adoption. And there's red for rather sparse adoption. That's what the pyramid actually shows. Let me try to explain what standardization of industry-approved open specification means in detail. I take an example for this, which is NMOS. NMOS with its specifications is actually aiming for unifying various mechanisms of operational control, from the discovery and registration of devices to basic stream control, parameter control, channel mapping, and finally authentication or authorization, to just name a few. As systems installed are never heterogeneous, never homogeneous, always heterogeneous. That means that no system install out there is realized as a single vendor solution. To get along with this, when you apply or install such a system, unification of operational control is highly appreciated. So interfacing between products of different vendors is not hassle-free. It's most likely costly and comprehensive in very few cases. So you aim for a unification. Devices usually offer proprietary control APIs. I think I need to click once. So we see those control APIs over here. So devices usually offer proprietary control APIs for external controllers to get access into system parameters. Understanding these APIs is and was ever the job of the overarching broadcast control system, which has a driver for those APIs. If no driver exists because of the API is new or has been updated, then the control system needs to learn about this driver. It needs to be developed, and that is a human task. As engineers are coding drivers, which generates costs, those drivers usually get typically monetized. And since quite a while, we do, as a manufacturer, we do not face projects without NMOS being a key requirement. Some even request NMOS as a binding requirement. So the reasons for this are obvious. A technology shift introduces new products and mechanisms. New products come with new APIs, and new mechanisms require different handling. So consequently, the need for the adoption, especially in control layer, increases dramatically. Avoiding vendor lock-ins through proprietary solutions is a key task, which is aiming or screaming for open specifications. If edge devices and controllers, overarching controllers, integrate common control specifications, the responsibility is spread, so the costs are spread. Unification as such through open specifications therefore is good. That's what you want, that's the way forward. To be very clear, implementing NMOS into a device which is not speaking NMOS is also an engineering task, and therefore it is expensive. So you have to have an engineer doing the task, and most likely at the end this task is going to get monetized. The charming bit around implementing NMOS is it is just one implementation, and you might save money thereafter, because the integration of existing NMOS devices is actually a given afterwards. So back to the pyramid. I mentioned the color codes of the pyramid. Let's specifically look at the yellow and the red sections. Why are these colored yellow and red? The adoption of unifying standards, which were actually meant to simplify cross-vendor integration, are they stalling? So why don't vendors just go forward and invest into a continuous integration, into maturing a specification? Well, let's get back to the example to understand what it is about the bad of the lack of the integrations. So a closer look at NMOS specifications helps to understand where we are at present. There are actually 6 NMOS specifications listed: ISO 5 registration and discovery, ISO 4 registration and discovery, ISO 5 connection management, and ISO 8 audio channel mapping are actually stated stable by the MBAR. ISO 4 and 5 are facing a broader acceptance nowadays. Compatible devices and systems can be found across the industry. They are existing from many manufacturers in all segments. So the wide acceptance may lead also into a further growth as these topics are literally understood and well accepted. So how could your product then benefit from the increasing compatibility? Many vendors state compliance, and industry organizations like, for example, the JT&M Workgroup provide verification and certification of vendor solutions in regular tests. The next one, by the way, is in fall 2022. You could watch out for those batches listed over here. ISO 8 is actually at the beginning of this acceptance increase, but it is not yet there. One of the reasons for this is that many devices out there which could use ISO 8 for channel mapping are based on existing well-proven platforms. What would that mean? Channel mapping in these devices is usually addressing I/O matrices, so the signal order before the packetization or the signal order after depacketizing. And those systems provide actually existing solutions to address the baseband matrix control. And it is actually not necessary to have any urgency on creating another API on top which does exactly the same. So sometimes there's even not a possibility to add something on top of a legacy device because there's simply no space for additional code. And this means for ISO 8 that it will maybe see an increasing adoption after the advent of new IP native I/O solutions. And what about those other specifications over here? ISO 7 event and tally, ISO 9 system parameter, ISO 10 authorization. These specifications are currently in a stabilization phase, to be honest. And stabilization means that an implementation will need to be tested and verified against real-life measures. So can it be implemented? Will it scale? Does it misbehave somehow? This usually leads to improvements and reworks, and that goes so long until stabilization is reached. For manufacturers who go with a solution at this early stage, the risk is at hand. This means extra costs in time if engineers have to throw away code after a rework has to be implemented. So bad for the manufacturer, as this time cannot be invested into product evolvement, but also bad for the customer, as if it is deployed already in a configuration on site, you have to change it, which maybe lead to delays and additional cost. So given all these risks, vendor would usually wait for stabilization of a specification. This again begs the question of why vendors not just take the risk and mature a specification for an early acceptance. Well, let's look finally a last time at the pyramid. So as mentioned already, the pyramid shows three information, the different fields of application. It shows the recommended standards and specifications which are applying or recommended to solve the situation, and then the implementation progress in form of color codes. Beyond that, the pyramid shows a fourth information, and this information is actually the size of the slice. So if we look at the sizes of the slice and we take an example, for example, lowest one, security, the undergoing of applying security mechanisms onto an entire product portfolio is a huge undertaking for a manufacturer. Security can't just be applied to just one product, for example, in form of a simple login password dialog, and then you're safe. Security must be addressed as a horizontal approach onto all the products and a top-down approach from user interface down to the streams. So consequently, applying security measures is highly important, yet it is a time-consuming act of integration which is addressed with many vendors already, but it is still in the works, ergo we see this one as red. And not to forget, there is a last view on this, which is this one. If we take the pyramid, look a bit outside, away from IP integration, there are areas which have just rushed into focus, rather suddenly even, and they require attention and commitment at the same time. Over the past 2 years with the global pandemic, many of us and many of our customers have transformed their businesses in order to remain productive and to be able to deliver. Remote production and cloud-based workflows all of a sudden became the hot topic, and products which were not intentionally built for these environments were forced to adapt quickly. When you take a tour around these halls here, you will not find remote production being a topic anymore. It is a given. Remote production is a given and not longer a niche application. So there's broad acceptance, broad experience all over the place. It's not longer a niche, it's a daily task, and it accelerates currently into the cloud. So as a manufacturer, you can't say no to this, you have to address it. And the second one, you can't also say no to a forced redesign of electronics. Like never before, we have, as manufacturers, we have been faced and hit by the global electronic component shortage, which overran our industry in the last year. And price rises, for example, from $8 to $250 for just a silicon are not really an unreal situation anymore. So this leads us as manufacturers to, from one day to another, to source alternatives, to adapt our supply chain, and even if it is really worst case, we have to start redesigning existing product. And that is something you have to do right now in order to stay in the business. these tasks are not unreal, they happen, and that is also a cause why some things around implementation of standardization are a bit delayed. So what is our conclusion for today? There are reasons for the perceived slow availability of some specific standards and specifications, and these are directly related to our everyday work. Standardization across manufacturer technologies allows to find broad and rapid acceptance when there is no alternative and when they've reached stability. So you have to have a solution which is stable, and you have to have a solution where there's nothing out there which is alternative. Then you have a chance to succeed. If one of these characteristics is missing, the adaptation is losing momentum. It is important for us to understand that this should not and must not affect the projects we have out there. So these projects must not and will not suffer from this result, because it is all our interest as manufacturers to get projects done anyhow with standardized solutions or with stably working proprietary solutions. That was me. Many thanks for your attention. Thank you.